concentration of a solution in this unit, in this section. And as we are talking about the concentration of the solution overall, we learned in the last video that concentration just has to deal with how much solvent and how much solute is in the solution overall. So when you add this to this, we can actually mathematically calculate how much of the solute gets dissolved into the solvent. When you look at concentration, the more solute that is there, the higher the concentration. So looking at this one is more concentrated than this one if the red particles are the solute and the blue is the solvent. Typically, when we find the concentration, we use the capital M, molarity. However, there's a different way of calculating your concentration, and it's called molality. Molality is the moles of solute divided by the kilograms of solvent instead of liters. So the other one was moles per liter. This one is moles per kilogram. So it's just two different ways of calculating the solvent's amount that's there. Instead of looking at the volume, you're looking at the mass. So with your molality, we typically use these for math problems, especially with the freezing point depression and the boiling point elevation that we're going to look at in the last video for this unit. So when you're writing out your molality, it's a lowercase m. The molarity is an uppercase m, so that's the big difference between them, and you have to be very careful when you are writing them to make sure that you are really overemphasizing the capital M versus the lowercase m. So this is all messed up as well. The other one was too. I don't know why. We have your moles of solute divided by kilograms of solvent. The tricky part about these is you're going to see two different gram amounts. One of them is going to have to go to moles. The other one is going to have to go to kilograms. So we're going to have to figure out which is your solute and which is your solvent. When we're looking at that, remember you always have less of your solute than your solvent, so the bigger number will go to kilograms. Or the way that it's worded, it might say that, A is added to B. Because A is added to B, A is my solute, B is my solvent. And then when in doubt, water is your universal solvent. So if you can't figure it out any other way, use water. So with these, I don't know why this isn't going anywhere. There we go. You have a unit. The unit is just a lowercase m. The lowercase m means moles per kilogram, so moles over kilogram. You can write it like that, or you can write it with the lowercase m. I don't have a preference one way or another. Mostly people like the lowercase m because it's quicker. So with your practice problems, just like in your last video, I'm going to switch over to my document camera and I'm going to do two examples. I'm also going to show you the triangle method of solving these as well. So when we're looking at these, you have your little m is equal to moles of solute divided by kilograms of solvent. If you like the triangle method, your little m is equal to moles of solute divided by kilograms of solvent. To get your moles, the conversion factor, if you need it, 1 mole is equal to however many grams there are from the periodic table. And we haven't gone from grams to kilograms very often. Just like we did with milliliters to liters, you're going to move your decimal place 1, 2, 3 times in that direction in order to go from grams to kilograms. And that's because King Henry died by drinking chocolate milk, or you're dividing by 1,000. So it doesn't matter how you do that, but you're starting here with base and you're going 1, 2, 3, or you're dividing by 1,000. So looking at this problem, it says you have 4 grams of sugar, which is that compound, dissolved into 342.11 grams of water. What is the molality? So molality is little m of the solution. I need to figure out which one of these two numbers goes to moles and which one goes to kilograms. It says that sugar is dissolved into water. So this one I'm going to have to take to moles because that's my solute. This one I'm going to have to go to kilograms because that's my solvent. Kilograms is the easier of the two, so I'm going to do that one first. I'm going to move my decimal place 1, 2, 3 times. So you get 0.34211 kilograms. This is going to need to go to moles, so grams to moles. That means that I need to find the molar mass of this for my conversion factor. So you start with your 4 grams. 1 mole of that sugar molecule, we need to find the molar mass. So I have 12 times 12.01 for the molar mass of carbon, plus, here I'll just do it the long way, 22 times 1.01, plus 11 times 16. So when I plug all of that into my calculator, it gives me a molar mass of 342.34 grams for the mass of 1 mole. So 4 divided by that answer. This has 1 sig fig, so I need 1 sig fig here. So you get 0.01 moles. Once I have moles in kilograms, I'm just going to divide the two to get my little m. So 0.01 moles divided by 0.34211 kilograms. 0.01 divided by 0.34211. This number has 1 sig fig, this one has 5, so that means that in my answer I'm only going to have 1 sig fig, so you get 0.03 little m. So it's not very concentrated. That's a pretty small number, so the concentration is not very high. This one, it says how many grams of potassium iodide is Ki, must be dissolved in 500 grams of water to produce a 0.060 molal Ki solution. So, sorry, I didn't realize that was off of there. This one, if we look at my triangle, little m is equal to moles of solute divided by kilograms of solvent. It's saying that it's dissolved in 500 grams of water, so I know for sure, once I convert that, my kilograms. I also know my little m. Molal is little m, so I know that one. So if I know these two variables, I'm going to multiply them, and that's going to give me my moles. So I'm going to take little m times kilograms to give me moles. Now the answer wants grams, so I'm going to have to take it one step further once I get that answer. So my little m in this case is 0.060 times my kilograms. So 1, 2, 3 times I'm going to move that decimal. Before that conversion I had 4 sig figs, so I have 4 sig figs after, like that. So I'm going to get an answer. That answer is going to give me moles. So 0.06 times 0.5. I got 0.03. That has 2 sig figs. This has 4 sig figs, so I need 2 sig figs in my answer. That gives me moles. Now the question is asking for grams. So with the question asking for grams here, I'm going to take my moles and convert it to grams by using my 1 mole is equal to however many grams there are from the periodic table. So I need the mass of potassium iodide. Potassium on the periodic table has a mass of 39.10 grams plus 126.98 grams for the mass of iodine. So I'm going to take my 0.030 moles. 1 mole has a mass of 166.08 grams. Moles cancels, so now I just multiply these two to get my answer. 0.03 times 166.08. This number has 2 sig figs, so I can only have 2 sig figs in my answer. Oops. I have 4.9824. So that means that my 8 is going to make my 9 go up. So 49 is going to go up to 50. So we have 5.0 grams of Ki. So on this one, because it asked for grams in my final answer, I solved for moles first. After I solved for moles, then I converted moles to grams. If you guys have questions, ask. Otherwise, have a great day.